Hey guys, this is Miss Pasenka. I am doing Friday, August 23rd's lesson, and it is on Unit 1, Tools and Transformations. We are focusing on reflections today. I just wanted to quickly run through the slides with you so that if you had any questions or whatnot, you could probably get them answered by watching this video. So today, again, we are working on reflections. I'm making this video because we do not have live class today. So hopefully this will make it easier for you guys to learn the material today. And then you guys have exit ticket 1.07. So going back to what we learned on Wednesday, a transformation is a change. We did a transformation, well, most of you did a transformation Desmos activity. You can describe sizes, positions, and orientations of shapes under informal transformations such as flips, turns, or slides. In geometry, we have specific names for these. So on Wednesday, we worked on translations, which are slides. We describe a transformation as a one-to-one mapping between two sets of points. So with our translations, you can take one line and match it up with a point in your original image and then slide that direction and distance to another point in the final image. We have specific names for the original image, which is called a pre-image, and then the figure after the transformation is called the image. Reflections, rotations, and translations preserve the size and shape of the original figure. So the size, the shape, it stays the same. It does not get smaller or bigger. It does not change your shape. It does not change the orientation. Actually, sorry, it does change the orientation because, if you flip it or turn it, that changes the orientation, but it does not change the size or the shape. The image and the pre-image are congruent. They just sometimes look different depending on what transformation that you do with these three types of transformations: reflections, rotations, and translations. Any transformation resulting in an image that is congruent to the pre-image is called an isometric transformation or an isometry. Reflections, translations, and rotations, and we'll get to rotations next week, are isometries. These transformations follow rigid motion that map the pre-image onto the image. So we could, do a flip, a turn, a slide, and that would take our pre-image and be able to place that onto the image, which is that final image. I know there's a lot of words here, guys, but vocab. A reflection is a specific type of transformation that uses a line or line segment that creates a mirror image of the figure. So if you look in the mirror, that is your reflection. So basically there is a line or a plane that goes between you and the mirror. There is a line, and when you look into the mirror, your reflection is kind of flipped, right? So we think of a reflection as a flip. That line that we reflect the image across is called the line of reflection. I know, very unique name there. Furthermore, a line segment that connects a point and its image is perpendicular to the line of reflection, and the distance from the pre-image to the line of reflection is the same as the distance from its image to the line of reflection. So I will show you that in a minute. I know that kind of got a little wordy there, but it will make sense in a second here. So are the images reflections? This is what they were talking about. The red line is the line of reflection, okay? And this is not going to be a great color here because it's black, but basically, okay, you have these two, let's say the points of the arrows. They are the same distance away from that line of reflection, and they are perpendicular with that line of reflection. Again, if I focus on this, they are the same distance, and again, my lines are not the greatest. They are the same distance away, they are perpendicular, and that goes for every single point here. So yes, these two images would be reflections. We are taking the one and we are flipping it over the line of reflection. This one, now our line of reflection happens to be slanted or diagonal, so it does change things a little bit. But if I take, from this point to this point, or this point to this point, notice how I still do technically have a perpendicular line, and each point is the same distance away from its corresponding point. So those are reflections as well. Okay, this one, would it be a reflection? The answer is yes. If I were to, take this and flip it over a line of reflection that is vertical, the arrow would match up with the other arrow. Think of it as like you taking your hands, right? I don't know if I can turn my camera on now that I didn't start it. But if you look at your hands, right? If you flip them over and under, that is a reflection of each other. You can basically fold it over that line of reflection and the pieces will match up. For this one, is the line of reflection line M, or line N? So this can be a little tricky at times, but basically we need to visualize how we could like fold it, I guess, over that line of reflection, which we will talk about in a couple more lessons about how it's symmetric and whatnot. But if I were to fold it over N here, or flip it over N, that's not going to match up because this would end up over here when you make that flip. Now, if I do line M, okay, and again, you can use this to help you remember that our pieces, our corresponding points, need to be perpendicular to the line of reflection. So this obviously is not perpendicular to that line of reflection, so line M would not work. And then if I look at line L, okay, if I take this point, we are the same distance away from line L, same distance away, and it is perpendicular to line L. If I take any other point on C, all of those are also perpendicular. So line L would be the line of reflection there. Identify the line of reflection for the pair of figures. So again, we need to decide which one the corresponding points would be perpendicular to and would match up with a even amount of distance. So B is really close to this corner, but really far away from this corner. C looks like it could probably work, right? It might be a little closer to this one than this one, but it looks better than line A does. So line C would be your answer there. Also, the corresponding points would be perpendicular to that line C. Okay. For this one, because our shape is the same on both sides, like we could fold it hamburger or, from this point to match them up. We have actually two lines of reflection here, so we could reflect it over the line M. And again, if I take, if I take this point and this point, they would be perpendicular. And same thing, you know, if I take this point and this point, they would be perpendicular. You can also look at it. P would not work because it is not the same distance away from the right moon to the left, but N would work. Because if I draw in some lines here from the points, it is perpendicular to line N, and they are the same distance away from line N. So line M, whoops, not line N and line M would work. So sometimes you will have multiple lines of reflections depending on the shape. Okay, so our two figures are the triangles here. Okay, so this is much like the last slide. Lines of reflection, so obviously they need to be reflected or flipped over a line that is the same distance away from both figures. So B, yes, it could be the same distance away from both figures here, right? But in order for that to work for B, we would have to have a shape over here. So B would not work. D. D is really close to the bottom figure, but pretty far away from the other figure. So D would not work. C, if I were to take this point and draw a line, and I know that's not perfect because I don't have a ruler accessible here, but this line would be perpendicular to line C, which means that it is a line of reflection. Now the other one would be line A. And line A, if we look at it, we could take this point, right, and this point, or, and we can say, okay, that's the same distance away as this one is. Rather, let me think of it as this way instead. That is not right how I just said that. We are thinking about the other sides of the image. So like these two are the same distance away from line A, and they're perpendicular, okay? This point here and this point here, same distance away from line A, and it's perpendicular. So line A would also be an example of a line of reflection. Exit ticket 1.07 is what you are working on. Yes, you still have an assignment, even though we don't have class today. That is how it will always be. Even if your teacher is not in class for the day, if they are sick, you will still have an assignment to do. Please reach out with any questions. We are available by email or call. Texting is still not working for our phones for some reason, so please give us a call or email us if you have any questions. Thanks, guys. Bye.